Hi, in today's class we're going to look at energy. This is a very important concept. So far we've seen it, I think, in just one formula. In ideal gases, E trans is equal to 1/2 times N mm VRMS squared. But this is actually an example of a more general equation. N, the number of moles, times mm, the molecular mass, is the mass of the object. 1/2 times the mass of an object times its velocity squared is EK, the kinetic energy. So the E trans formula was just an example of the kinetic energy formula. And kinetic energy can exist both in motion, but kinetic energy in some ways can be stored. For example, if I put a pumpkin on top of the tower, and initially the pumpkin on top of the tower is not moving, it has no kinetic energy, but as the pumpkin drops, it had energy stored in it. It starts moving very, very fast. The energy was stored in it. This stored energy is called potential energy, EP, potential energy. And for the pumpkin, in feeling the Earth's gravity, the potential energy is the mass of the pumpkin times the gravitational constant of the Earth times the height. The higher it is, the greater stored potential kinetic energy there is, so EP is mgh. And we're going to be also particularly interested in potential energy where it refers to molecules, so atoms. So here we have a nucleus with Z protons, Z number of protons, and here is an electron, and their distance r apart. And that electron has feeling an attraction to the nucleus, so there is a stored kinetic energy. There's a potential energy, which is equal to C times the number of protons, which is capital Z, times the charge of the proton, times the charge of the electron, divided by the distance between the two. And we can look at this as a proportionality for electrons in atoms. EP is proportional to the charges are constant, is proportional just to Z, the charge of the nucleus, divided by the distance of the electron to the atom. And EK for electrons, which shall have all the same mass, is proportional to V squared. The next thing we can look at about using energy is that the total energy, E total, is the sum of the kinetic energy plus the stored energy, the potential energy. The stored potential energy can be turned into kinetic energy, and so since it's just turning one into the other, the total energy actually is constant. In the pumpkin case, initially, all the energy was stored as potential energy, but as it falls, it loses that potential energy and it's turned into kinetic energy. But the EK plus EP is constant to equal the total energy, and this is called conservation of energy. And that's point B. Electrons in atoms have another remarkable theorem. So electrons in atoms obey a theorem called the virial theorem. And it's a theorem about the average kinetic and potential and total energies. And the virial theorem says the average kinetic energy is equal to minus the average total energy of the electron in the atom, which is equal to minus 1/2 the average potential energy. And this is true for all electrons in atoms. One So written as a proportionality relationship for electrons and atoms, EK is proportional to ET, which is proportional to EP. And these are the three key proportionality relations that we'll be using when we discuss electrons in atoms. I would like to end with one final point. There is another kind of important particle that we have to deal with, which is the photon. The photon is the particle for light, and light is a wave, and it has no mass, and it has a different equation for its energy. Its total energy, ET, is equal to h times nu. Nu, that's the Greek letter nu, and it's the frequency. The frequency is how often a wave beats. H is Planck's constant. So, photons, light obeys a different energy formula, E equals h nu, and then we have the three key proportionality relationships for electrons in atoms. EK is proportional to V squared, EP is proportional to Z over R, and EK, ET, and EP are all proportional to each other. And we're going to use these concepts starting tomorrow, and we will continue throughout the semester.